Welcome back. My name is Martin Becher, and today we will talk about climate risk terminology. For this presentation, we will navigate with Muro, and we will imagine that we have two different scenarios. On the left-hand side, we have an earth dam, which is embedded in a valley with partially vegetation which is not in too good shape. This earth dam provides energy, which is on the one hand transported outside, but also gives energy to a village, which is quite next to the river. And the village mainly has its livelihood based on corn production. On the right-hand side, we have a concrete dam, which is within a valley that is in quite a good shape from an ecological point of view. This concrete dam also provides energy to the village, which is well embedded next to the river and mainly lives from tomato production. So let's have a look what kind of hazards could happen here. Let's imagine that we have exceptionally strong rainfall, and this earth dam from one day to another gets fuller and fuller and might even come to a point where it might even break. So we can suggest to analyze the hazard floods. So the floods are threatening this earth dam, and they are also exposing the earth dam, and the consequence could potentially be that the whole system of interest, meaning the earth dam plus the village downstream, might suffer. So a hazard can be described according to IPCC Assessment Report 5 as the potential occurrence of a natural or human-induced physical event or trend or physical impact that may cause loss of life, injury, or other health impacts, as well as damage and loss to property, infrastructure, livelihoods, etc. And we also see that the houses downstream would definitely be exposed, at least those that are located next to the river, to such a flood. So exposure has to do also with the geographical location. Let's have a look at both dams. Are they both similarly sensitive to such an increase in water pressure, if we assume that here the water level is increasing as well? I would say they are not, because a concrete dam is less sensitive to increased water pressure than an earth dam, of course. So sensitivity has to do with the intrinsic characteristics of an infrastructure, a person, an ecosystem, or whatever system of interest we are looking at. Let's assume that we have this area here, and the pressure of the water is increasing more and more. What would be assets that would help to increase the adaptive capacity of the system of interest? Of course, the sensitivity here is one aspect. But if we would, for instance, think about having an additional thermal power plant in place, we could also say that by installing such a thermal power plant, we would ensure business continuity management by increasing the business continuity management capacity of the system, meaning that there will be a redundancy in the electric or power system. So even if the dam stops providing electricity, there is a certain redundancy because the thermal power plant will provide energy instead. Similar to the earth dam. Let's say right now we do not see any means of servicing this earth dam. But if we would decide to put an operator's house next to the earth dam, we could also define that operators that work nearby the earth dam are there to assess whether the risk is increasing or not. Also regularly assess if the earth dam is in well shape and operated well. And if available, also put an alarm in place that may warn the community downstream. So adaptive capacity can be defined as the ability of systems, institutions, humans, and other organizations or organisms to adjust to potential damage, to take advantage of opportunities, or to respond to consequences. When we assess both sensitivity minus adaptive capacity, we are able to define the so-called vulnerability. So vulnerability is the propensity or predisposition to be adversely affected. Vulnerability encompasses a variety of concepts and elements, including sensitivity or susceptibility to harm and lack of capacity to cope and adapt. So once we analyze both systems and we see that they are exposed to this hazard of floods, they are sensitive to them, and they only have a certain level of adaptive capacity, we could therefore also come to the conclusion what the potential impact is. So the potential impact could be, for instance, that the earth dam breaks. It's not able to provide electricity anymore, and it will flood the downstream valley, probably also flooding many of the houses. So we could work on a couple of measures, for instance, to reduce exposure by putting the houses on a safer place. We could reduce maybe the sensitivity by building other types of houses, or by having landlines over here that withstand floods, or maybe also by adjusting the infrastructure. Let's say building a higher earth dam or replacing the earth dam by concrete dam. We could also work on the coping capacity, for instance, by installing a thermal power plant, or by teaching people what to do in case the alarm siren starts to work. Having financial funds also increases financial adaptive capacity, simply because we will be able to restore our community back to normal once something happens. And what also helps is to have physical and operational robustness capacities in place. However, we still have not spoken about risk. So what is the difference between potential impact and risk. The difference, in fact, is that we have not considered so far the probability for such an event to happen. So although the potential impact of such a flood is very high, for sure, if the probability or likelihood is very low, the risk for loss may be quite low as well. So especially when we talk about climate change, it's also important to look into the short, medium, and long future and assess if likelihoods may change on the longer run. So let's say maybe nowadays it is quite unlikely that such an extreme rainfall event may hit our region, but on the long run, it may be critical. Also, if other types of events happen or are about to happen on the medium or long run, let's say from having a nice and well-shaped ecosystem at the river to having an erosion of the ecosystem in the future, this might increase the likelihood of strong rainfall developing into a flood, simply because the infiltration capacity of the ecosystem will be eroded, and therefore larger flood masses may hit our region. So once we assess our potential impact and we also add likelihood or probability to it, we are able to define climate risk, which is defined as the potential for consequences where something of value is at stake and where the outcome is uncertain, recognizing the diversity of values. Risk is often represented as probability of occurrence of hazardous events or trends multiplied by the impacts, if these events or trends occur. Risk results from the interaction of vulnerability, exposure, and hazard. From this end, I would like to invite you to freeze this image, read the definitions in your own pace and time, and learn them well, because you will for sure need them in the rest of the training. Thank you so much for your attention, and looking forward to meet you again in the next session. Goodbye.